Okay, good day everyone. Welcome to this lesson video on descriptive statistics. Before I start, please allow me to start with a prayer first. Dear Heavenly Father, I just want to thank you for this day that you have given us. Lord, we acknowledge that you are the source of all wisdom, of understanding. We pray for help in gaining understanding in this lesson. Lord, help us also to offer up to you everything that we do, that in everything may your name be praised and glorified. Help us, dear God, that in everything we may acknowledge your goodness to us. And all of this we pray in the name of Jesus Christ, your Son. Amen. Okay, so again, we are here in the lesson of descriptive statistics. As you would note from our previous lesson, descriptive statistics is one of the two major types of statistics. And we have descriptive statistics and inferential statistics. And in this lesson video, we will be particularly studying descriptive statistics and how to compute it using real statistics in our computer. Okay, so I would assume, I hope and I pray that you have already read the journal article on descriptive statistics, which I have sent you through school book. Okay, so before that, let me just give you a walkthrough of what you will be doing. In your research, you would be conducting your research online. You will be gathering your research online. So this is an example of my previous research on remote learning. Okay, self-efficacy of parents in remote learning setup, remote learning and homeschool setup. So this is how I did my Google form. I have sent this Google form survey to my friends and other people who could respondents in this research. So I have sent this through social media, through Facebook, Messenger, and email. So I have sent this this data gathering survey online. So you would see here that, say for example, age is an item that the respondent has to supply by typing in the actual information. And for this one, for the position, this is a multiple choice item wherein the respondents would just have to click a button and then presto, that data would be reflected in the worksheet. Okay, and all of these are coded. Okay, so ito, pag kumuha ka, ito yung mga questions, and then you will see the responses, and this is now the worksheet file. Ito yung worksheet that you can download. Okay. And once you download it, this is what it would look like. Okay, so dito siya lalabas. Ganito. This is how it looks like. So it's still raw data, which you have to transform, to recode and transform. So for example, here in this item, that where the respondents have to respond whether they agree or disagree. They have to respond their degree of agreement to this kind of item. I know how to help my child do well in school. So, for example, here, respondent 1 says that he agrees or she agrees. So, ayan, agree or sumasang-ayon. So, what I did was to recode this. And one way to recode this is to use the find and select function and then replace, or you could use the custom sort or a sort and filter function. And so this is now how it looks like, coded and transformed. Okay, so say for age, so clean na siya. These are already the responses which are coded and coded already, coded into numbers that Excel can understand. So age 46, 36. So I did not have to recode it already because the information were in actual numbers. Okay. Now for this one, for the specific items in the scales that I used, I had to recode them. So ayan. So for our convenience, I just copied a portion of the variables that I wanted to show you for us to compute for descriptive statistics. So this is now our data set, and there is a need for us to present this data set not in this manner, because imagine I have here 135, so this is 135 respondents. There are so many information here, and if I would be asked as for a particular information, it would be taxing for me, very taxing for me to, give away all of the data here. So I would just have to encapsulate or summarize the data from here using descriptive statistics. So a data set is a collection of the data. So this is a data set, and it is a collection of the data of individual cases. So this is case 1, case 2, case 3, okay? Individual cases or subjects. Usually, it is meaningless to present such data individually because that will not produce any important conclusions. In place of individual case presentation, we present summary statistics of our dataset with or without analytical form, which can be easily absorbable for the audience. Statistics, which is a science of collection, analysis, presentation, and interpretation of the data, have two main branches. These are descriptive statistics and inferential statistics. Okay? So summary measures or summary statistics or descriptive statistics are used to summarize a set of observations in order to communicate the largest amount of information as simply as possible. Now there are three kinds of descriptive statistics. We have the measure of frequency. This would be the number of occurrences in a data set. Then there would be measure of central tendency, which uses the mean, the median, and the mode, and then the measure of dispersion or variation. The measure of frequency is used for categorical data or for nominal data or categorical data. We use it to report such kind of data. It is a frequency statistic that simply counts the number of times that in each variable occurs. For example, the number of males in a classroom. So say, for example, there are 38 males and there are 20 females. So how many percent of the males, how many percent of the females? Then we also have the measure of central tendency. If you have read the journal article, there are three major kinds of measures of central tendency, and these are the mean, the median, and the mode. The mean is used if you have a variable that is measured on the interval or ratio scale. So meaning to say you have a quantitative data. It has weights or amount, okay? And median is used if you have interval scale, if you have an ordinal scale variable. Say, for example, sibling position, ordinal position in the family, that is that is ordinal. Then median is also used if you have data that is that have outliers. Sobrang marami yung outliers. That means extreme scores. In a data set, there is a probability that there are extreme scores. Scores that are very far from the mean, from the average score. And usually they set a problem in your data set. So you cannot, if you have such kind of data, you cannot use it. The mean is not appropriate to use as measure of central tendency. Then you use the median. Okay, for example, and then the mode is the most frequently occurring score. Okay, so the mean, the median, and the mode. For example, this one. In this list of income of 5 employees, we have here 135,000, 54,000, 37,000, 32,000, 35,000. If we will try to report the income of these 5 employees with only one number, and if we choose the mean would be 57,089. And do you think the mean is the most, or is more appropriate than using the median? Because the median would only report 37,668. Why is that? Because this data set has outliers, meaning to say extreme. Kagaya nitong 135,000, ito siguro, this one is very far from the middle scores. So the most practical or logical measure of central tendency would be the median, 37,000, because 37,668 it more closely approximate the other income here, not the 57,089, because 57,000 is way above here, which is very far from the mainstream income. So you also look at your data set. If there are many outliers, just like this one, that would tend to pull down or pull up the data, the information, then you may have to use the median, okay, not the mean. But if your data set is fairly normal, meaning to say there are very few or only one outlier, or maganda, if there is no outlier at all, then you use the mean. In processing your data, if you see outliers very far from the mainstream, the usual thing to do is you may delete them from the data set. That is one thing. That is one way of data screening. The measure of variation is used. This tells us how spread the scores are in our distribution. Kung gaano kabuhaghag yung mga scores sa distribution natin. For example, this one. So there are three sets of scores here. We have here set A, set B, and set C. All of these, they all sum up to 20. Yung summation nila ay 20. They all sum up to 20, 20, 20. Okay, they all have the same value, 20. They all sum up together to 20. However, which do you think here, which set do you think is the most spread out and the most, what's this, homogeneous? The most heterogeneous or the most homogeneous among these three sets? Okay? When you say the most homogeneous, this is the one that is not very spread out. The scores are fairly consistent or uniform, and that would be set C. Ito, as you would see, there is no standard, walang variation, lahat 4. Okay? Lahat 4, although they also sum up to 20. So the standard deviation for this is 0. Walang variation, pare-pareho. Ito medyo spread out ng konti, but the very heterogeneous set of data here is set A. Ito masyadong varied. So, may 1 ang score, meron naman extreme ang score 7. Okay? So, my lowest performing, my highest performing. So this is the most heterogeneous, set A, and the most homogeneous is set B, set C, I mean. Okay? Now, for example here, ito. Suppose this is data from 3 schools, UP, Ateneo, and LaSalle. So the average or the mean rating of these 3 scores are all the same, 87%, 87%. Now, if you would look at these scores, which do you think is the school that is the best performing? Is it UP, Ateneo, and LaSalle? So, since they all have the same mean scores, can you use this as a clue for you to make any conclusion from the data? No, it is not, kasi pareho lang naman sila ng mean scores, 87%. But then, looking at the SD, you would see that UP has the Ateneo has the highest standard deviation, and LaSalle got the lowest standard deviation or measure of dispersion. This means to say that the scores of students who took the board exam, okay, of LaSalle students who took the board exam were the most homogeneous, mas magkakalapit ang kanilang mga scores compared to Ateneo and UP. And if you would look at this data, the best performing is LaSalle and the poor performing is Ateneo, because although they all have the same mean scores, 87, but most likely with this kind of standard deviation, there are people who have very high score, but there are also people who have very low score. But compared to LaSalle, all of the students are somehow congregated, they flock, okay, all together to the mean. Isa lang, halos magkakapareho, homogeneous yung scores nila. Kaya mas maganda ang performance as a school ng LaSalle. Okay? So that is measure of variation. Now, let us look here at the data set. How do we compute for this? Say, for example, this is not a data set. This is about parent-child relationship and self-efficacy. So this data this column is for self-efficacy scores and closeness and conflict for column D and column E. So column D is for closeness and E for conflict. Say, for example, respondent here 1, his age is 46 and type of school setup is homeschool, and his score in self-efficacy is 53, and closeness score is 35, and conflict score is 17. Now, suppose you want to know the descriptive statistics for self-efficacy. Okay, ito, self-efficacy. We'll try to see here. Now, what you will do is click, dito tayo, click Control M. Okay, press Control M together. At lalabas ito, Descriptive Statistics and Normality. Now, suppose hindi lumabas yan, punta ka dito. Make sure that you already have installed the RealStat in your computer. You go to, where is that? You go to File. You go to File, and then click More, and then Options. This is if you are using Windows, and then click Add-ins, and then click Go. And I have already, dito kasi naka ano na yung RealStat ko, no? Naka-check na. If it is already checked, tapos hindi pa nag-work yung, your RealStat is not yet working, you just uncheck it and click OK. Uncheck it and click OK. And then you go back again to File, then click More and click Options and click Add-ins, click Go, check again X RealStats, okay, and click OK. So for me to start, I will Control M. So this is now Descriptive Statistics and Normality. So there are many options in Real Statistics. So we have your Descriptive Statistics and Utilities. Under Descriptive Statistics, you would see here, marami dyan mga function keys that you can use, but we will be using Descriptive Statistics for this lesson video. So dito, may regression, we have ANOVA, time series, multivariate, correlation, miscellaneous. But we will focus on this, Descriptive Statistics and Normality, so I click OK. Okay, so for example, I would like to get the Descriptive Statistics for conflict. So I will just highlight conflict here. There. And I will check column headings included with the data, because when I highlighted the column, I included the label. Okay, so column headings included with the data. So I will check Descriptive Statistics, and I will not use this, and I will use Shapiro-Wilk. I click Shapiro-Wilk and Descriptive Statistics. Okay, so these are defaults here, and I will delete the defaulted range here. So I will indicate here my output range. I will choose this. Just click a cell here. Dito, side by side sa data mo, so you can easily see the result. Okay, so there you go. Okay, so you have here the mean. So the mean for conflict of the 135 respondents is 15.0889. Okay, so when you report your data, you report it into decimal places. So 0.08, so that would be 0.09 na siya, 0.09, no? Or you can report that as 15.09. Okay, so this is now the standard error. So this is a measure of dispersion. Standard error is the approximate difference between sample mean and the population mean. Remember that this is a sample only. This 135 people is just a sample of parents who are homeschooling and remote learning their children. So it is not this is not the total population of parents who are doing this remote learning and homeschooling. So I just got a sample, and this standard error reflects the difference of the mean, okay, of the sample, of this particular sample from the population, of the total population. So this is not the estimated standard error. So the mean is a measure of central tendency. So since conflict is a variable that is measured in the interval or ratio scale, I use this as for my reporting of descriptive statistics. So the mean. Now the median is 15 and the mode is 17. You would see that the mean and the median and the mode are fairly the same. They're almost, except for the mode, which is 2 points higher, but the mean and the median are the same. You would see that somehow this may be this distribution is normal. And then we have here the standard deviation. The standard deviation is 4.91. This would indicate how spread the scores are. And the sample variance is 24.14. So this is the sample variance. Now, the sample variance is just the square of the standard deviation. So if you multiply this standard deviation by itself, you will get the sample variance. Now, if you get the square root of sample variance, then you get the standard deviation. They are basically the same. Now, if you want to report a smaller figure, then you can choose standard deviation for your reporting. The kurtosis and the skewness. Why do you need this kurtosis and skewness? The kurtosis and skewness would indicate, this would be your indicator of whether your distribution is normal. Again, it's a picture of the bell curve or the normal distribution. In any population of people, it is assumed that the population of people would reflect that of a bell curve, meaning to say that most of the people fall under the average, and less than the average, less than that, okay, number of people would fall dito sa fringes of the majority. Okay, this would be the fringes of majority here. Okay, say for example, for IQ, it is assumed that the distribution of people in terms of intelligence would reflect this picture, the normal curve, wherein 68% of people would fall between the first standard deviation of the positive standard deviation, first standard deviation, and the negative first standard deviation. So this would be 68%. Okay, from here, because the normal or the average IQ would be 100, okay? And this would be standard, this is a standard deviation of 0. Now, if your IQ is between 100 to 115, that means you are within the first standard deviation above the mean of 100. So that is positive 1. Now, if your IQ is below 100, and that would be between 100 and 85, so your IQ is within the negative 1 standard deviation. Now, this would be negative 2 standard deviation, and this would be -3 standard deviation. Now, somebody whose IQ is 70, whose score in the IQ test is 70, it is said that he falls within the -2 standard deviation below the mean. Now, for those people, 68% of the population, they say normally the population is pictured this way. Most of the people are within this range that would be from first -1 standard deviation to +1 standard deviation. Now, only few people, that would be 14% of the population, would fall within, okay, the range of 1 standard deviation to 2 standard deviation above the mean. So this would be 14%. Okay? Now, from here, ito, from the mean, which is 100, to 2 standard deviation below and 2 standard deviation above, that would be comprised of 95% of the population. Okay, now for those people who belong to the level of Einstein, Newton, they are around here. That would be 0.1%. Okay, very few of the people belong in this class, in this category. That is already above 3 standard deviation. That would be 3 standard deviation above the mean. Okay, 2% are within this 2 standard deviation above the mean. And so also are the poor performers. There are people, 2% are below 2 standard deviation. And there are only 0.1%, not even 1%, 0.1% below the -3. So there are only very few people who are really, intellectually challenged. Nandito siya. So most of the people belong to this group. Ito, nandito. So this is supposed to be the normal curve. Ito, this is supposed to be the normal curve. Okay, so for example, what is the implication here? For example, if you are if you are an owner of a shoe factory, how many shoes? You know that what is the average shoe size of a Filipina woman? No, of Filipina women. So you know that the average shoe size of Filipino women is around 6 inches, 5 to 6 inches. So you would, based on this normal distribution, in your production of shoes, you would be producing shoes na ang size that is of the average size. Say for example, you would be producing shoes that are 5 feet to 6 feet, mga 68% of your production would be composed of shoe sizes within that range, 5 to 6. Now, if you would produce shoe sizes for women that are let's say 12 or 10, maybe you can produce only 2% for that, because there are only few women who would be buying that size of shoes, because most women would fall here in the 68%. Okay, maybe you can size 7, size 8, dito 14% siguro. You can produce 14% of that shoe size because they comprise around 14% of the population. So the same thing also, for example, if you are a restaurant owner, you follow this kind of distribution in your production. Okay, so that is just a practical application of this bell curve. So that is now so that is about bell curve. Now, not all distribution follow the bell curve. This is very ideal. This is very ideal. In actuality, your bell curve could be, they could differ in terms of kurtosis and skewness. Kurtosis refers to the peakness of your distribution. Okay, there are three types of kurtosis. There is what we call the leptokurtic, the mesokurtic, and the platykurtic. Now, this leptokurtic, which is the thin one, this is in green, this is leptokurtic, and the red one here, that is the meso, that would represent the normal curve, and the platykurtic is the flat here, the blue one here. Well, the if you have a leptokurtic or a platykurtic distribution, that would indicate that your distribution is not normal and it is not resembling the normal curve here. So, if that is the case, there are implications here of further statistical techniques that you would have to use, because you cannot use the mean as your measure of central tendency if your distribution is not normal. Maybe you can use the median instead, and you cannot use the t-test or the standard deviation, the t-test or the ANOVA if your distribution is not normal. So there are considerations in the use of this data. So you have to test the normality of your data by looking at the kurtosis and the skewness of your data. So this is only a visual representation of how it is in your normal curve. The normal curve looks like this. Now, in a positive skew, the tail is to the right of the distribution and the mound is leaning towards the left. Nandito. This means to say that most of your people belong to, let's say, for example, if it is an achievement test. So many of the people fall below the mean score. Say, for example, if we will plot the mean score here, this is the mean score, this is the average score, and if this is the mound here of the distribution, this means to say that most of the examinees have scores that fall below the mean scores, and few belong here. So maraming outliers. There are many outliers here because there are still people who got the very high grades, but they are just very few. But ito, no, there are many here. Look here, the mound is here and it is below the mean. And the negative skew, however, the tail, this is the tail. The tail is on the left side and the mound is itong mataas dito, the mound of the curve is here on the right side. So this means to say, if we will plot the mean score here, there are most of the people who took the exam, the achievement test, got the high scores, higher than the mean score. So that is skewness. So this is positively skewed and this one is negatively skewed. So these are the considerations that we have to look at if we will check for normality of our data. Okay? So, kita natin dito that the kurtosis is 0.38076 and the skewness is 0.4614. So, ano ba yung sinasabi? You can use the Shapiro-Wilk. The Shapiro-Wilk, ang sinasabi ng Shapiro-Wilk, it is not normal, sinasabi niya. Bakit? Kasi the p-value is less than 0.05. Again, Shapiro-Wilk is a statistical test that it is a statistical technique to test for normality of a distribution. Now, if the p-value here is less than 0.05, ito ha, I will, if p value is less than 0.05, then the distribution is not normal. Okay? So, yan ang sinasabi. Since this p-value is 0.000465, that is why Shapiro-Wilk here says, no, that distribution is not normal. However, contradiction naman sila ni D'Agostino Pearson. Si D'Agostino Pearson is this is another statistical test of normality. Dito kay D'Agostino Pearson, ang sinasabi niya, if the same pa rin, if p-value is less than 0.05, then the distribution is not normal. Pero magkaiba yung kanilang, they have different computation. Dito, its p-value is greater than 0.05, so that is why its conclusion is that this distribution of conflict, okay, it follows a normal curve. It is normal. Tapos, and if you would look at the kurtosis is not very high. The kurtosis and the skewness are not very high. Hindi siya malapit, hindi sila malayo masyado. Although itong kurtosis is negative, medyo this is a little bit platycortic, this leaning to platycortic, but it is not very far from 0. Okay, 0.38 and 0.46. So it's still in the researcher's judgment call whether based on this, no? Kasi Shapiro-Wilk test, if you would use Shapiro-Wilk test for big numbers, say for example for data set greater than 50, it becomes very sensitive. Parang halos lahat sasabihin niya not normal. Pero if the distribution includes less than 50 cases, Shapiro-Wilk is the most appropriate normality testing technique to use. Okay, so I would lean towards declaring this as normal based on the kurtosis value and the skewness value, because it depends also on who are you following, because according to central limit theorem, I am looking here for the, okay. According to central limit theorem here, it states that the distribution of sample means approximates a normal distribution as the sample size gets larger, regardless of the population's distribution. So the sample sizes equal to or greater than 30 are often considered sufficient for the CLT to hold for the central limit theorem. So according to this, okay na yung 30. So that would be sufficient enough to approximate a normal distribution. Okay. However, this is different. Okay, this viewpoint differs among authors. Like for example, this one. According to Altman, DJ, and Bland, and then another article by Gazimi and Sahid Yazel, they say that 100 or more observations. So sabi nila, a sample size of 100 or more, then violation of the normality is not a major issue. So it's not just 30, but they say it should be 100 or more. Saka ka makaka-relax that you can assume that the distribution must be normal already. But for Lamort and the other authors, like I cannot remember other authors, they say at least 30 or more. However, for meaningful conclusions, the assumption of the normality should be followed irrespective of the sample size. So that is why we conduct statistical tests like Shapiro-Wilk. If it is if your sample size is less than 50, then you can rely on Shapiro-Wilk. But if it is more than 50, then you look at the kurtosis or skewness and try to see this interpretation. Okay, for small sample sizes, which is n is less than 50, if absolute z-scores for either skewness or kurtosis are larger than 1.96 at alpha, point zero distribution is non-normal. So how do you know this? Let's say, for example, for medium-sized sample 50, the sample size is greater than 50 and less than 300, this one. If z-value is greater than 3.29, an alpha of 0.05, distribution is non-normal. So let us take this example. I will have, I will insert columns here so I can have space to do this. For example, we have to transform the skewness into z-values. Ano ang sabi dito? If z-value is greater than 3.29, distribution is not normal. So for us to declare this as normal, we have to hope that the z-value for this skewness is less than 3.29. So we have to transform this into z-score, into z-value, okay? So how do we transform this into z-value? Skew value over standard error for skewness, okay? Then the z-value for excess kurtosis is z-value for kurtosis is excess kurtosis over standard error for excess kurtosis. So where do we get this? Itong z-value for skewness. Where do we get this skew value? We get it from here. This is now the skew value. And then how about the standard error? The standard error for skewness is not given here in Excel. Ito is standard error for the whole ano to eh. So we have to compute. Well, so this is now the formula for standard error for skewness. Standard error for skewness it is equal to square root of 6 over n. N is the number of samples. Okay. Then the standard error for kurtosis is square root of 24 over n. N is equal to number of count for samples. Okay, so this one, in this particular example, we have 135. Okay, so I will we will look at either of the value for skewness and kurtosis. So let us see this skewness, standard error for skewness, square root 6 over n. So I will have here equal sign. Okay, if you put in a formula, make sure that you start with an equal sign, then square root. Lalabas yung mga function keys dito, but I will just type square root. Okay, then the number, so 6 over, what is my count? 135. I will just click this. This is the count. Ito yung count. It is equal to 135. And close parenthesis and enter. So this is now the standard error. So again, the formula for z value for skewness is z skewness is what? Skewness value over standard error for skewness. So that would be, tama ba yung formula natin? Yeah, skew value over, okay. So dito, papasok. Again, following this formula for z value for skewness, which is skewness value over standard error for skewness. Okay, again, I will type in the formula, equal sign, then what is the skewness value? I will click this, highlight, and then divide by standard error. This is now the standard error. And click enter. Okay, this is now the value for the z value for skewness, that is 2.188674. Let us look at the interpretation. Okay. Since I have 135 samples, this is now considered as medium-sized sample. So 50, okay, this is greater than 50, less than 300. If z value is greater than 3.29 at alpha level of 0.05, my distribution is non-normal. Okay. So if z value is greater than 3.29, so this is 3.29. So this is now our quota. Ito yung maximum natin, 3.29. Let us look at the z value. The z value is 2.18. This is interpretation. Okay, the Z value for skewness is 2.18 or 2.19, which is less than 3.29. Okay, it is less than 3.29. So therefore, ang sabi, therefore, the distribution is normal. This distribution for conflict is normal. Bakit? The Z value is 2.18, which is less than 3.29. Okay? It is not above 3.29, so therefore I can safely conclude that my distribution is normal. If Z value is greater than 3.29, distribution is non-normal. Okay? Now, for example, larger than 300, either an absolute value of skewness of greater than 2 or an absolute kurtosis proper larger than 7, distribution is non-normal. So the skewness that is greater than 2, then it is not normal for distribution of more than 300. So you first have to compute this. Yung ibig sabihin nito, both my D'Agostino-Pearson, which is a statistical test to determine whether my distribution is normal or not, it says yes, the distribution is normal, and the Z value for skewness is 2.18. This indicates that the distribution is normal. Now, how do you report this in terms of APA? Okay, how to report descriptive statistics? So we have here rounding numbers to decimal places. Okay, so we have here 1.23 because the next number here is less than 5, so we retain this on the second decimal place, we retain the number 1.23 still. And then 1.676, since the third decimal place is greater than 5 and above, then we round up the second decimal place number. So from 1.67, we round it up to 1.68. Now, how about 5? This is 1.425. So what shall we do since this is 5? So we round this up to the next higher number, this 42, it becomes 1.43 because 5 here is followed by 6. And how about this one? The third decimal place is 5 followed by 3 zeros and then 1 at the last decimal place. So still we round this up to the next higher number because 5 is followed by a number at the last decimal place. How about for this one? For a 0.4250000. Although even though this is 5, we still have to retain the second decimal place number because 5 is not followed by a number value higher than 0. So yan, 0.42 pa rin siya. The same thing dito, 1.6750000. So retain this as 1.67 because 5 is not followed by a number higher than 0. The same thing dito. So you see the pattern? Okay, so that is the rule for rounding numbers. Okay, and you spell out numbers or use numbers appropriately. Numbers less than 10 are typically spelled out, 5, 7, but numbers greater than 10 are typically represented with digits. Numbers starting a sentence are always spelled out, regardless of size, such as 47 participants refused consent. Okay. Now, abbreviations. For mean, you italicize all the abbreviations. The mean is abbreviation is M, and standard deviation abbreviation is SD. I will be sending out, I think I have sent out this PowerPoint presentation. The average reaction time for the 12 participants, you always report the number of samples, and then the mean. Okay, this is now the mean, 820 minutes. In close parentheses, SD, which is italicized, equal to 192 in the treatment group. But the mean reaction time was only 642 minutes, and then followed by SD 183 for the 11 participants in the control group. The 16 teenagers who volunteered for the pilot study were younger than expected. Their mean was 14.2 years and SD is 1.3. You can also include here, let's say, for example, you say the distribution of age of the participants was normal, and then you can write here kurtosis, E is sabihin natin 2.2 and Z value for skewness is 1.3. Okay, so that is how you report your descriptive statistics. And for this lesson video, you have learned how to compute for descriptive statistics of your data set and how to interpret your data, whether it's normal or not normal, based on Shapiro-Wilk test and based on kurtosis and skewness. Okay, we also learned about the measures of central tendency and measures of variation. Now, I would like you, if this thing is not yet very clear with you, I would like you to go back to the article about descriptive statistics and try to compute the worksheet that I have sent through school book, and try to compute on your own, so you can practice and compute for descriptive statistics using the data set that I have sent in through the school book. So that's it for this lesson video. I hope things were clear regarding descriptive statistics. Good day and God bless you all. Okay, so see you next class.